Welcome to MSBT online learning platform. We brings you the most relevant content in an exciting digital format. Today we will be studying a very interesting model from the applied mechanics which includes topic friction, where we will be studying some interesting facts about friction and we will be practicing some of the example based on it. So let's begin. Dear friends, today we will going to learn very interesting topic in applied mechanics model, friction. What do you mean by friction? For better understanding, do an exercise. Take your palms like this and just press it and then slide each on each other. What you experience, it is a resistance to the motion or sliding. This is nothing but the friction. There are three learning objectives. First, to understand basic terms in the friction and laws of friction. Second, to use the condition of limiting equilibrium on the block problems. Third, to understand FBD means free body diagram of ladder in the friction. There are four learning outcomes. First, determine the force of friction and coefficient of friction for given condition. Describe the conditions of the friction for given situation. Determine the frictional force in the given situation on the block and identify the various forces acting on the ladder with given conditions using FBD, free body diagram. There are numbers of examples related to real life in which the friction plays vital role. First example, we can't even walk if friction is not there. Our shoes or sandals having a specific design at the bottom which create a grip, it is the next example of friction. When running vehicle, the tire having a grips, so it avoids the kneading. This is the another kind of friction. We can't hammer the nail in the wall if wall having no friction. We can't light even the matches if the friction is not there. And the most important in our day-to-day life, any machine or mechanism having a friction. Without any mechanism or every mechanism having a friction, without that the machine can't run. Our bicycle is very good example of various types of friction. When bicycle is in rest position, we are applying the pedal forces to start the bicycle. It is on the verge of motion, then the friction comes static friction. When it is in rolling condition on the road, it is called as rolling friction between the tires and roads. After we apply the brake, and it is sliding friction. Now we will see the relevance of the friction with various subjects. In third semester for civil engineering, mechanics of structure and for mechanical strength of material, the friction comes. In fourth semester for civil engineering, geotechnical engineering and hydraulics and for mechanical theory of machine, this topic used. In fifth semester for civil engineering, precast and pre-stressed concrete and for mechanical peoples, elements of machine, and in sixth semester advanced steel and RCC design, the friction is used. For studying the friction, prerequisites are as following. You must know the mathematics and trigonometry, then knowledge of resolution of the forces, and we require the conditions of equilibrium and its knowledge. First of all, friction. What do you mean by friction? Resistance offered by the contact surface of one body to other body is in the motion or on the verge of sliding is called as friction or frictional force. Now, what are the advantages of the friction? For walking on the road, friction is required. Moving the vehicles are stopped by applying brakes. This is also friction. Hammer the nail in the wall. This is also friction. And holding the pen and writing, the friction required. Apart from this, the excess friction causes some disadvantages. What are they? First, loss of energy. Second, wear and tear of the machine parts. Third, more consumptions of the fuel. Fourth, reduction in the efficiency. We can't avoid the friction, but we can minimize the friction by the lubrication. Now we can classify the friction based on the motion. There are two main classifications. Firstly, static friction and secondly, dynamic friction. In static friction, the body is on the verge of motion. It is in rest condition, so it is called as static friction. In dynamic friction, the body is in motion, so it is called as dynamic friction or kinetic friction. Dynamic friction or kinetic friction is now subdivided or classified in two parts. One is sliding friction and another is rolling friction. Now, based on surface condition, friction is classified as when surfaces are dry, then called as dry friction. When surfaces in contact is wet, then it is called as wet friction. Now we will see theory of friction. For this, take one block, place on rough surface and apply the pulling force P. The self weight which acts from its CG vertically downward direction. To balance this self weight, the normal reaction which is perpendicular to this plane, to balance the frictional pulling force, this frictional force which is tangential to the surface but opposes the motion comes in the picture. Now, if I increase the pulling force P, the frictional force will also increase and the graphs come in picture with applied force and frictional force is a straight line. On the maximum, it is on the verge of motion, so it is called as limiting friction. At up to this is a static friction and afterwards it is a dynamic friction. Now, there are three conditions of limiting friction. If pull force is less than the limiting friction, body is in rest condition. If pull force is equal to F, means frictional force, body is in limiting equilibrium. This is very important with us. Then when pull force is greater than the frictional force, limiting friction, then body is in motion. Now we simplify this figure or block in this way. Frictional force F opposite to this pull force and normal reaction is opposite to this self weight of the body. For P is equal to F, body is in limiting equilibrium. Now we can use conditions of equilibrium as summation Fx is equal to 0, summation Fy is equal to 0 and summation of moment is equal to 0. Also, we have seen that frictional force is directly proportional to normal reaction. If I equals frictional force to the normal reaction, the mu comes in picture. Now what is mu? Mu is the coefficient of friction. Coefficient of friction is nothing but frictional force upon normal reaction. Now laws of friction. Coulomb and Morin gives the laws as follows. The first law is frictional force always acts tangential to the plane of contact and in the direction opposite to the impending motion. This is very important. Frictional force is always opposite to the motion. And second, force of friction is self-adjusting and it increases as applied force increases up to the limiting friction. Next, when the body is in limiting equilibrium, the limiting friction bears a constant ratio to the normal reaction. This ratio is called as coefficient of friction. The coefficient of friction depends only upon the nature of surface, whether it is rough or smooth. It is not dependent on surface area. And the static friction is always more than dynamic friction. Now the next term, angle of friction. Now take same body, same block with free body diagram. When I draw the resultant of frictional force and normal reaction, it is like this, called as S. Now the angle between resultant force to normal reaction is called as angle of friction. Now what is the role of this angle of friction? Before it, how to calculate S? S is the resultant of frictional force and normal reaction. Now S is equal to square root of F square plus R square. It is nothing but a Pythagoras theorem. And angle of friction is calculated by tan inverse F by R. This is F and this is R. Tan inverse means front side upon this adjacent side. But we know that F by R is mu. Hence, there is a relationship between coefficient of friction and angle of friction. In other words, if angle of friction is known to us, coefficient of friction to be calculated. Now, what do you mean by angle of repose? Now, what do you mean by angle of repose? For this, one horizontal plane which is rough in nature, keep one end intact and lift the another end with the block placed on it. At a certain inclination, alpha moves downwards on the verge of motion in the downward direction. This angle of alpha is called as angle of repose, where angle of repose is defined as the angle made by the inclined plane with the horizontal plane at which the body placed on an inclined plane is just on the point of moving down the plane under the action of its own weight. No external reaction is provided on that block. Now if I draw the free body diagram, just on the verge of motion, it is in condition of limiting equilibrium. It includes motion is in downward direction, so frictional force is in upward direction. Normal reaction is always normal to the plane, and this self weight is vertically downward direction. This angle of inclination is nothing but now angle of repose. Now by the trigonometry, this is also angle of repose. Resolve this W in two components. one component is W cos alpha, which is adjacent to alpha, and another component is W sin alpha. Please remember, you have to resolve the inclined plane along and across. Now, what is mu? Mu is equal to F upon R. But in this, for balancing, F is equal to W sin alpha. So, keep F is equal to W sin alpha. What is R? To balance R, W cos alpha. So, put R W cos alpha. Then mu is equal to tan alpha. Here is alpha. Alpha is angle of repose. It is tan inverse of mu. Hence, the coefficient of friction is nothing but tan of angle of repose and tan of angle of friction. Do you have any question?
Yes, sir. I have question. Which friction is a more static or dynamic?
Very nice question. Static friction is always more than the dynamic friction. Why? To start the body from the rest condition, it requires more force. Hence, the static friction is more than the dynamic. Do you have got my answer?
Yes, sir. Thank you.
In this, we discussed two types of problem: block on a horizontal plane and block on a inclined plane. Now, block on a horizontal plane and force is parallel to the plane. Force is pull. This is the first type of problem. In this, because of pull force, body is just on the verge of sliding. What is the free body diagram of this? Motion in along the self weight is vertically downward direction, normal reaction is vertically upward direction, and the most important, when motion is in this direction, it opposes by the frictional force, which is called as now mu r. For this, we can use limiting conditions of the equilibrium. Summation Fy is equal to 0 means W is balanced by this R, and Fx is equal to 0 means P is balanced by this F. Is now P is equal to mu R. When same block, but it is in the push, force is now push. What is the motion of the block? It is in the direction of push. Now, free body diagram of this, motion is in this direction, self weight vertically downward, which is balanced by this R, means normal reaction. Now, motion is in this direction, direction of the push force, frictional force opposes that motion, it is mu R. Now, use conditions of equilibrium in this. Summation Fy is equal to 0 means here also R is balanced by W, and summation of Fx is equal to 0 means P is balanced by F. Now, P is equal to mu R, F is nothing but mu R. Now, block on horizontal plane, but force is inclined to the plane. Previous problems we have seen the block is on horizontal plane, but force is parallel to the plane. Now, in this problem, the pulling force is inclined with theta degree to the horizontal plane. In this type of problem, resolve first pulling force in two directions orthogonally along the plane and across the plane. Along the plane, the component is P cos theta, across the plane, component is P sin theta with self weight W and normal reaction R, same as it is. Now, for limiting equilibrium, summation of Fy is equal to 0 means what? To balance W, R and P sin theta is there, and to balance P cos theta, F is there. F is equal to mu R. Now next problems are block on inclined plane, force just to stop the motion. This is one inclined plane. When block placed on this, body start to move. Why? Because angle of inclination is greater than angle of repose. Now what is the free body diagram of these types of problems? Very simple, same one. P force is required to stop the motion. The self weight W is acting vertically downward from its CG. When motion is in downward direction, the frictional force is always upward direction. But in this case, W is not along or across the plane. So resolve this. Along the plane, W sin theta, and across the plane, W cos theta. Now use the conditions of equilibrium. Now for limiting equilibrium, Fy is equal to 0 means what? R is balanced by W cos theta, and Fx is equal to 0 means what? W sin theta is balanced by two forces, P and F. P and F, where F is equal to mu R. Now block on inclined plane, but to start the motion, P required, like this. With the P, we have to start the motion. On the verge of start of the motion, the equilibrium conditions are there. Now, see the free body diagram of the same block. When we start the motion with P, it is on the verge of motion, so it is in limiting equilibrium. Means what? This force is P, which is start the motion, and W is in vertically downward direction, but here motion is in upward direction, so frictional force is in downward direction. This is the main change. W is resolved by two components along the plane and across the plane. Along the plane, which is adjacent to theta, called as W cos theta, and remaining is W sin theta. Now using these conditions of equilibrium, for limiting equilibrium, summation Fy is equal to 0. Fy is across the plane. R is balanced by W cos theta, and Fx is equal to 0. Fx is along the plane. P is now balanced by W sin theta, and F is equal to mu R. Do you have any question?
Yes, sir. I have one question. How to fix the direction of frictional force?
Very good question and nice question. As we learn in laws of friction, the direction of frictional force is always opposite to the motion. Just think the motion of the block and go the opposite to it. This is the direction of the frictional force. But remember, the frictional force is always tangential to surface. Do you understand this?
Yes, sir. Thank you.
How to draw free body diagram of ladder? Now this is the wall and this is the ground on which the ladder is slanting down. I want to draw a free body diagram of ladder. These are two contact surfaces, intact with wall and intact with ground. Due to the self weight which is acting at a centroid of this ladder and vertically downward, ladder will slide in this way. Now the position of this ladder changes in downward direction for wall due to motion, and position of the ground, contact point of the ground is away from the wall due to the motion. It slides downward direction. For wall, frictional force is in upward direction. For ground, it slides away from the wall. Frictional force is opposite to the motion. Now whether rough surfaces or smooth surfaces, when it is in contact, the normal reaction is always perpendicular to contact surface. For wall Rw and for ground Rg is there. Now this is where coefficient of friction between the ladder and ground is called as mu g. Coefficient of friction between the ladder and the wall is called as mu w. Rg is the normal reaction at the ground, Rw is the normal reaction at the wall. Force of friction between the ladder and the ground is Fg. Fw is the force of friction between ladder and the wall. Do you have any question?
Yes, sir. I have question. How many conditions of equilibrium are used in ladder problem?
Very nice question. For this, take the free body diagram of ladder. How many unknowns? One is normal reaction of this, frictional force of this, but they are interrelated to each other. F is mu and R, and it is interrelated. F is mu and R. It is related to mu and R. Hence, this is one unknown, this is another unknown. To solve the two unknowns, two conditions of equilibriums are required, but they are not concurrent to each other. For these types of problems, three conditions of the equilibriums are used. First, summation fx is equal to 0, summation fy is equal to 0, and summation of moment is equal to 0. I hope you have understood this.
Yes, sir. Thank you.
With this lecture, we understood the basic terms in friction and laws of friction. Using the condition of limiting equilibrium on the block problems and to draw the FBD of ladder in friction. Now you are fully competent to solve the problems of friction. So worksheet is given below, try to solve it. Example first, given block on a horizontal plane with pulling force 38 Newton and W is equal to 100 Newton. But pulling force is 30° to inclination. Pulling force is 30° to horizontal surface. The student make mistake here. in resolution of the forces. Adjacent to P is P cos and remaining is P sin. Motion is in this direction. So, what is the frictional force opposite to that motion is here in opposite direction. For this, calculate coefficient of friction and total reaction S by using conditions of the equilibrium. We are using summation of Fy first. Why? Because in summation of Fy, R and W is known, W is balanced by R. So, start in these types of problem from summation of Fy, it is better. R is equal to now 81 Newton. Fx is equal to 0. Second condition means P cos 30 is balanced by F. F is equal to mu R. Mu is now calculated. Now, S is calculated by Pythagoras theorem. S is nothing but reaction resultant of the frictional force, which is 87.42 Newton. Now, second, the same block is there of 100 Newton weight, but it is placed on inclined plane 30 degree and motion is downward. To stop the motion, what is the force required? Now, here, although the P force is in upward direction, but motion is in downward direction. To stop this motion, P is required. The mistake is here. Always do mistake here. P force, motion is in downward direction. Frictional force is always in upward direction. This shows frictional force in downward direction. For limiting equilibrium, summation Fy is equal to 0 means this R is balanced by 100 cos 30. Again, the W is vertically downward direction and R is normal to the inclined plane. Now, W is resolved in two components. Why? Because our plane of X is like this and Y is across the plane. So, resolve 100 cos 30 and 100 sin 30. What is the P? To just stop the motion, 15.36 Newton is the pull. Now, the third problem. The same block is there of 100 Newton, coefficient of friction is same, inclined plane is also same, but to start the motion in upward direction, draw free body diagram. In this free body diagram, now the motion is along the direction of the pull. Study the motion and draw the direction of frictional force F opposite to that motion. Pull force required just to start the motion in upward direction is now 84.64. Means what? From previous problem, approximately 15 to 84, there is no motion in the block. Firstly, try to understand the basic concept of friction. Secondly, try to understand the motion of the body on the planes. Remember that frictional force is always opposite to the motion and normal reaction is always perpendicular to the plane. Resolve the force along and across the plane only. Along the plane is your x-axis, across the plane is your y-axis. You have learnt some important topic so far and we hope that you had a good time learning with us. Browse through our online library for more content on MSBT website. Thank you. Stay connected. Happy learning.